Alright, so continuing from our last video on matrix multiplication, we ended on example 11. We're going to move straight into example 12, where we're going to have a row matrix 2, -8, and we're multiplying it by the matrix 3, 10, -4, -3, -2, -7, 5, -6. So because the number of columns in the first matrix does match the number of rows in the second matrix, we can do this multiplication. So we're going to end up having a matrix where we go 2 times 3 plus -8 times -2 is the first element. The second element is going to be 2 times 10 plus -8 times -7. And then the next element is going to be 2 times -4 plus -8 times 5. I'm going to run out of space, so I'm going to just put a line here with an arrow. The last element is going to be 2 times -3 plus -8 times -6. Now let's do the multiplication. So in our next line of work, we're going to have 6 plus 16, 20 plus 56, -8 minus 40, and -6 plus 48. Now we can do the addition. 6 and 16, that's going to give us 22. 20 and 56 is going to give us 76. -8 minus 40 is going to give us -48. And -6 plus 48 is going to give us 42. And we're done with example 12. Let's do a couple more. Let's aim at getting through at least example 15, and then maybe we'll do 16, maybe we'll just move on. So, example 13, we're going to take the square matrix 9, -5, multiply it by -2, 4, and multiply that by -3, 13, -5, -1, -7, 2. So, because the number of columns in the first matrix matches the number of rows in the second, we're good to go. We're going to end up with a 2-row by 3-column matrix. So, we're going to have 9 times -3 plus -5 times -1 in the first element. We're going to have now in the second, we're going to have 9 times 13 plus -5 times -7. And then in that third element in the first row, we're going to have 9 times -5 plus -5 times 2. Now in our second row, we're going to have -2 times -3 plus 4 times -1. And we're going to have -2 times 13 plus 4 times -7, -2 times -5, plus 4 times 2. Now we can do the multiplication. We're going to have negative 27 plus 5. We're going to have 117 plus 35. We're going to have negative 45 minus 10. And then in the second row, we're going to have 6 minus 4, negative 26 minus 28, and 10 plus 8. Now we can actually do the addition and subtraction. So our product, our final answer, is going to be in the first row, negative 22, 152, negative 55, and our second row is going to be 2, negative 54, and 18. So now let's move on to example 14, where we've got a column matrix, 14, negative 2, negative 6, and a row matrix, negative 1, 9, and 5. Since the number of columns in the first matrix matches the number of rows in the second, we can multiply it. Our resulting matrix is going to be a 3 by 3 matrix. So we're going to have 14 times negative 1. We're going to have 14 times 9. In this case, we're not adding because there's not multiple parts in the row or column. And then 14 times 5. And then our second row is going to be negative 2 times negative 1, negative 2 times 9, and negative 2 times 5. And then our last row will be negative 6 times negative 1, negative 6 times 9, and negative 6 times 5. So we just have to do the multiplication this time. Our final answer is going to be in the first row, negative 14, 126, and 70. In our second row, we're going to have 2, negative 18, negative 10. And in our third row, we're going to have 6, negative 54, and negative 30. Now let's move on to example 15. We're going to have the following. We're going to have 2, negative 8, negative 1, 15, negative 3, and 4. And then we're going to multiply this by 0, 7, negative 2, 11, 6, negative 5. So we're going to start by writing out our multiplication, everything we've got going so far. In our first row, before moving on, we do see that the number of columns does match the number of rows. We've got 3 columns in the first, 3 rows in the second. We're good. We're going to end up with a 2 by 2 matrix. So we're going to go 2 times 0 plus negative 8 times negative 2 plus negative 1 times 6 in our first element, in our first row. And then we're going to have 2 times 7 plus negative 8 times 11 plus negative 1 times negative 5. And now we can move into the second row. We're going to have 15 times 0 plus negative 3 times negative 2 plus negative 1 times 6. And then for the very last element, we're going to have 15 times 7 plus negative 3 times 11 plus negative 1. Oh, I made one mistake. In this second row, the very third thing, it's not negative 1 times 6, it's 4 times 6. And then the last part of this last element is 4 times negative 5. Now we can do the multiplication. We're going to end up with 0 plus 16 minus 6, 14 minus 88 plus 5, and then we're going to have 0 plus 6 plus 24, and 105 minus 33 minus 20. Now we can combine things with the addition and subtraction. We're going to end up with the resulting matrix of 10, negative 69, 30, and 52. So let's now look at example 16. We've got time. We're going to have negative 7, a row matrix, negative 7, negative 5, by a column matrix, 16, negative 1. So we can do this one pretty quick. We're going to have our resulting is going to be a 1 by 1 matrix. So we're going to have negative 7 times 16 plus negative 5 times negative 1, which is going to give us negative 112 plus 6, which is just going to be negative, correction, I made one mistake. It's not plus 6, it's plus 5. I added when I should have multiplied. And then the resulting matrix is going to be negative 107. All right, let's look at example 17. So, off to the side, and I'll write these in a second. Given matrix A and B, we're going to find AB and BA and figure out what can we conclude from our results. So if you remember back in middle school math, AB times BA, that is the commutative property. So in a way, what I kind of want us to get from this example is, can AB equal BA? Because the commutative property says that they should be able to. So our matrices, A is going to be 3, negative 1, 4, 8, so a small square matrix, and B is going to be negative 2, 10, and 7, 6. So first let's do AB. AB, we're going to have 3 times negative 2 plus 4 times 7 for that first spot. And then we're going to have, in fact, I made one mistake. Not 4 times 7, it's going to be negative 1 times 7. And then in the second element of that first row, we're going to have 3 times 10 plus negative 1 times 6. And then we're going to have 4 times negative 2 plus 8 times 7 and 4 times 10 plus 8 times 6, which is going to give us negative 6 minus 7, 30 minus 6. It's going to give us negative 8 plus 56. And then it's going to give us 40 plus 48. Which means our final matrix for AB is going to be negative 13, 24, and 48, 88. So let's see if we switch the order. If we go B times A, if we get the same thing. So now we're going to have negative 2 times 3 plus 10 times 4 and negative 2 times negative 1 plus 10 times 8. Then we're going to have 7 times 3 plus 6 times 4 and 7 times negative 1 plus 6 times 8. Which, if we do the multiplication, that's going to give us negative 6 plus 40 and 2 plus 80 and 21 plus 24, as well as negative 7 plus 48, which if we then combine everything through addition, we're going to end up with 34, 82, 45, and 41. Which those two matrices are not the same. So what we can conclude is that AB does not equal BA, which means, if we're thinking about some properties, that the commutative property does not work with matrices. That's really what we needed to get from that example. And based off time and how much we have left of these notes, we're going to call this good on this video. We'll get the rest of our examples done in our next video.